on the email and see if anyone emails. But today we have Dr. Seth Sykora Bodie recently, who is a graduate of GGE department in Slippery Rock University in 2011, and he graduated in the geography program. And then I'm going to let Seth introduce the rest of his degrees because I can't keep track of all of them. So, welcome, Seth, and thank you for joining us today. And have at it.
Yeah, well, thanks, Julie. I'm going to be looking back and forth. Maybe if I do this, that might help a little bit between two screens here. I've been trying to get this set up while we were waiting, but thanks for having me. It's really, it's really nice to be back and to see all of you. It's been a long time. Like Julie said, I graduated in 2011, and I went to the University of Maryland for a dual master's in conservation biology and in environmental policy. And so I was there in DC for about 4 years. I worked at Department of the Interior, I worked at the World Wildlife Fund, and then I moved over to NOAA, to the Fisheries Service, on a fellowship, a federal fellowship. And I was there for about a year and a half, and I really enjoyed my time. And that was kind of what led me back to school again. I thought, well, for a lot of the work that I want to do, I think that having a more solid grounding in research would be really useful, would be really helpful. So like Julie said, I graduated from GGE. I was in the geography program. I also studied political science and French. And for the last 5 years now, I've been at Duke, and I've been working on my doctorate, and it's really focused on environmental decision making and sort of large scale conservation planning efforts. So thinking about how it is that we implement conservation programs and make them more or less effective, what it is that sort of leads to successful outcomes in these instances. So there's an element of environmental policy to it. There's an element of conservation science to it, and thinking about how protected areas are designed. And to a large extent, there's also this element of sort of like human behavior and interactions as well. So today, what I thought I would do is I would talk a little bit about four different things. So my research, we'll get to eventually. I'll give you a little bit of that. But I also thought this is just a great opportunity for me to talk about conservation more broadly, about conservation science, about protected areas, and then about Antarctica, right? So I don't know, how many of you have other classes that have focused on Antarctic conservation, but hopefully that's something I can bring to you today. So it's just a four-part talk, and I could go pretty much all day, but I'll make sure to cut it off at a reasonable time here, and we might even ditch one of my chapters that I was going to talk about. So to start, let's see, where did I want? Is there anything else I wanted to say before I get started? So my research, like I've sort of been hinting at, is really based to a large extent in the field of conservation biology, and ConBio suggests that conservation is really about reducing human impacts and stressors on the environment, and trying to conserve biodiversity in situ, so where we find it, right, in the environment, as opposed to ex situ in a zoo. And how is it that we go about doing this? Well, in recent years, there's been this global effort to establish protected areas for about 20, 25 years, since the signing of the Convention on Biological Diversity in 1992, which really sort of jump-started that process. And the idea behind protected areas is that we're really trying to separate biodiversity from the different processes or anthropogenic um, events or activities that sort of threaten the persistence of it, of wildlife where we find it, right? But one of the problems with this is that we always have to make different decisions about how we're going to do that, because really we have limited time or resources, or we have imperfect knowledge about how particular environments and ecosystems function. So how do we go about designing protected areas? How is it we think about implementing them or establishing them around the globe? Well, so within conservation biology, there's this sort of subfield of planning, which really focuses on trying to understand how it is that we prioritize space, right? We select places for establishing different types of protected areas. It also really helps us understand how it is that we can go about engaging with stakeholders, and also really efficiently allocating scarce resources, right? So I was just saying we don't have unlimited funding for conservation. We don't have as many people working in conservation as we might need. And so we have to think about how we can really be efficient about where we establish protected areas. So on the left here, you can see an image. This is sort of the cover of the IUCN's guidelines for protected area management categories. And the IUCN is the International Union for the Conservation of Nature, which is sort of the UN's global biodiversity monitoring agency to a large extent, right? And on the right-hand side from that manual, I've got this quote here, which defines a protected area. And it says, a protected area is a clearly defined geographic space that is recognized, dedicated, and managed through legal or other effective means to achieve the long-term conservation of nature with associated ecosystem services and cultural values. So what I study are marine protected areas, or as I'm going to refer to them through the rest of this as MPAs. And they are frequently also called marine reserves or ocean sanctuaries. And you can think about them like national parks, right? Like Yellowstone, but in the ocean, okay? And it's 2020, and so, especially in this particular department, I think everyone here really understands or knows how it is that humans are having impacts on the natural environment. So here on the top right, this is an image from a Ben Halpern paper back in 2015, and it's showing how the oceans are being impacted by various human activities, right? So overfishing, pollution, climate change, those sorts of things. And the areas in the darker red have a higher impact than the areas in the lighter blue. Okay, this is just sort of a hotspot map of global oceans. And marine protected areas are just one of the tools that we have at our disposal for conservation purposes, right? So conservation scientists and international organizations are really trying to use them to achieve a wide variety of objectives, so sort of planning and conservation objectives, right? So they could be used for biodiversity conservation, for fishery management, for improving water quality, and more recently, this is becoming a big thing. So for improving resilience to climate change and also for storing carbon, right? We're thinking about how wetlands, how salt marshes can, mangrove forests can be sinks for carbon, right? So here on the left-hand side, I've included another graph. This is actually a pretty up to date, and it's just showing the growth in protected areas over the last, I think, 20 years. So you can see there's been an enormous increase in the last 10 or so, right? So I've talked a little bit about what a protected area is, and you've seen how fast they're growing around the globe. So what I wanted to show here is just the extent of them, where they're found, okay? And you can see that most are located around small island states or territories, right? So in the Pacific, there is a lot of area that's protected, okay? What you can also see is that here in the US, we're really lagging, right? We're behind significantly compared to a lot of other countries. So while we do have a significant area that is included in protected areas, most of it is in really remote parts of the world, okay? So the sort of, what's the word I want here? The spread of that, or sort of the representation of our protected areas isn't very good. It isn't very high. So lots of ecosystems that we might want to protect are not, they're not protected through protected areas, but they might be protected in other ways, right? There might be fishing regulations. So anyways, this is kind of where you're seeing a lot of protected areas around the globe right now, okay? And I guess I wanted to ask this question and sort of like base this is sort of the premise of a lot of my research and what a lot of conservation biologists are thinking about. They say, so what is it that makes protected areas successful? And there are a few things. So of course, the ultimate goal is they need to protect biodiversity, whether it's a rare species, a threatened habitat, could be a unique landscape. There are lots of things that we might want to protect in a national park or a marine protected area, right? But there are all these other sort of factors that sort of feed into whether or not those objectives are actually achieved. And so you can think about it this way. There are a number of different sort of social or economic or political factors that really influence the effectiveness of protected areas. So a lot of the research that has been done over the past decade in particular has shown that protected areas are much less likely to achieve their stated objectives if they don't account for human needs and activities, right? So what people are doing in the local environment. So we could set aside a protected area, in the Florida Keys. But if there are no regulations sort of managing how humans are acting, if it still permits unlimited fishing, if it still permits oil and gas exploration, then of course it's not going to achieve some of those objectives that we set in the first place, right? Like trying to improve the number of a threatened or endangered species that lives in that particular area. So this interdependence between humans and nature is really at the heart of conservation planning and efforts to ensure that protected areas achieve their conservation objectives. Yeah. So I'm going to stop there, and I'm going to change directions for a little bit. So this is the second part I want to talk about. I want to talk about Antarctica. I don't know how much you've gotten of this in the past, but I find, when I started at Duke, this was not at all my plan. I didn't think I was going to work on Antarctic conservation, and I slowly got sucked into it over the course of my first and second years there. And so what I wanted to do was just give you a real sense of place, because it's a pretty incredible one. And it's, I don't know how many of you noticed, but it's the coldest and it's also the driest continent on Earth, right? So for comparison, I looked up some facts for you all. And while the US is about 3.8 million square miles, it turns out that Antarctica is about 5.5 million, right? So Antarctica is much larger than the United States. Its tallest mountain, Vinson Massif, is 16,000 feet high, so it's actually higher than the Rockies. Parts of East Antarctica are actually 1.5 miles below sea level, although you wouldn't know this because the ice sheets are miles thick, so it makes them above sea level, right? And additionally, I could probably spend this entire hour just giving a lecture on Antarctica's role in regulating the Earth's climate, but what I'm going to say here is just that that role really revolves around reflecting sunlight back into space and informing the cold oceanic currents that really circulate heat around the planet, right? So if you take Julie's class, you'll probably get a lot more detail on that. So Antarctica's ice sheets, they also contain about 70% of the planet's fresh water. And if they were to melt, that would raise sea level by an estimated 200 feet alone. And they're estimated, this is my last fun fact, they're estimated to be about 500 million metric tons of krill in the Southern Ocean, which is an enormous amount, right? And by weight, I think some estimates have that as the largest of any species on the planet. Okay. But, a lot of my focus, as I think I've sort of talked about so far here, is on Antarctic management and sort of conservation and governance. And if we're going to talk about that, where we really need to start is with the Antarctic Treaty. Okay, so for decades, there were a number of territorial claims in Antarctica, and you can see 7 of those here on this little map. So the United Kingdom, Norway, Argentina, Chile, France, New Zealand, and Australia, they all had claims to Antarctica. And the United States and Soviet Union, of course, as you might expect, they reserved the right to claim the entire continent, okay? But in 1969, on December 1st, the Antarctic Treaty was signed. And this is an image from that first meeting the next year in Australia. And the charter of the Antarctic Treaty, it said that, quote, Antarctica shall continue forever to be used exclusively for peaceful purposes and shall not become the scene or object of international discord. So the charter, it goes on for a few more pages to talk about furthering the principles of the UN Charter and trying to encourage scientific investigation. And this is like a really key point that I want to get at here, is that from the outset, these signatories, all these countries who joined and signed the Antarctic Treaty initially, they were really focused on trying to preserve the continent and its waters for peaceful cooperation. And that is, it's really unique, right? Up until this point, a number of countries had these claims to the continent. So it's really inspiring that this could happen at the height of the Cold War. This is one of the first examples we have of sort of widespread international environmental cooperation, right? So if you want an example, this is one of the best places to start, okay? And that's actually been really inspiring to me, and that's kind of part of what led me to my own research, which has focused on the Convention on the Conservation of Antarctic Marine Living Resources, so CAMLAR, okay? And this is a sub-agreement. This is a convention that sort of falls underneath the Antarctic Treaty. And this is what I've been studying for the last 5 years, okay? So CAMLR entered into force back in 1982 with the express objective of conserving Antarctic marine living resources. And they do this through an ecosystem-based approach, which is part of what makes it really unique, because most international agreements managing the oceans or managing species, they focus on a single species. They focus on tuna, they focus on something else. And in this case, the way that the CAMLR Convention is written, it really encourages us to look and think about the ecosystem as a whole, about ecosystem integrity, about ecosystem function, about the role that krill play in the ecosystem, right? So it's not just how do we manage krill fisheries, but we want to make sure that we're managing krill fisheries in such a way that reduced krill counts are not going to impact whale populations, penguin populations, those sorts of things. And those interconnections are what's really unique about this particular agreement. Okay. So CAMLR is composed of 25 different member states and the European Union. And there are also a number of additional delegations, sort of observer delegations, like the IUCN, the Convention on Biological Diversity, the Krill Industry Fishing Association. And so these groups get together every year and they make decisions at various meetings, right? At working group meetings, at their annual negotiations in October. And these are consensus based. And this is really important to understand. So some international agreements, they have majority vote. Some have forgetting the term right now, but they require 3/4 of the members to agree to any proposal for it to be implemented. In the case of CAMLR, it's consensus based. So every single country has to agree. And in practice, what that really means is the absence of any objections. Okay. So you might read about this a little bit in news. Every October, this just happened. I was up at 3 a.m. every morning for meetings that were based in Australia. And you get these articles, right? So this year, John Kerry wrote a piece in the New York Times. So under his leadership at the State Department in 2016, there was a large MPA that was established in Antarctica. And so you start reading more about these discussions and negotiations to establish more marine protected areas. Okay. So this is just a quick map to show those countries. The ones in the dark gray here are the signatories. The ones in the light gray are the acceding states. So they sort of have observer status. They are official members, but they don't have sort of voting powers within the agreement. And I wanted to talk a little bit about all the different things that CAMLR manages. Okay, so I said that it's the agreement that's responsible for the Southern Ocean surrounding Antarctica, for the marine environment. And fishing is probably the most important thing that CAMLR manages, but it's not the only one. And so I've included a few other examples here, right? So over the years, CAMLR has really worked hard to reduce the accidental killing of seabirds in fisheries. So what we call bycatch. So this is when you're fishing for a particular species and you get some non-target species, right? You're looking for toothfish and you accidentally hook a bunch of seabirds that are going after bait, right? So that's the image I've got here on the top. CAMLR also plays a really big role in sort of enforcing all of these fishery regulations, and they have patrols from member states that operate within the convention area and enforce those regulations. CAMLR has also been really focused in the last couple of years. It's kind of growing. There's an interest in plastic pollution. So we think of CAMLR as being so remote that it's pristine environment, and it turns out that's not the case, right? All global oceans are connected, and so it turns out that we're finding lots of plastic washing up on the beaches in Antarctica. Okay. CAMLR is also starting to sort of like push and try and encourage more research on how climate change is going to affect the Antarctic marine environment, not just the continent itself, not the global environment, not how it is that the continent itself plays a role in sort of global climate systems, but thinking a lot about what those changes are going to mean for the Antarctic marine environment. Okay. Another thing that CAMLR has really been starting to do in the last few years is work with tour companies to ensure that their practices are sort of safe and sustainable. Okay, so that they're not impacting the continent or sensitive species, habitats, that they're not bringing in plants or wildlife from other continents, those sorts of things. Right? So the other thing, though, of course, and this is kind of where I'm going with this, that CAMLR plays a huge role in, or they have the authority to do, is establish marine protected areas. And these protected areas are supposed to achieve a few different things. So first of all, they want their MPAs to be representative and contain or protect some type of every ecosystem and species that we find in the Antarctic marine environment. They also want to protect sort of ecosystem processes. So I was talking a little bit about how the agreement, the convention, focuses on these interrelationships, like these interactions, sorry, between different species or between species in the environment. They also really want NPAs to be scientifically valuable. So you can think about them as useful for sort of baseline monitoring of the marine environment, for helping us understand the impacts of fishing in one place while also having another nearby location that's unfished, to sort of understand how removals from the environment are affecting the overall sort of ecosystem, right? Of course, I mean, closely tied to all that is they want to protect vulnerable areas, whether these are sort of deep sea, whether they're around seamounts where we find higher levels of biodiversity. And they also really want MPAs to help maintain resilience in the face of climate change. Right? So the concern is that, and this is sort of complicated to sometimes explain, but it's not necessarily that marine protected areas are a tool for fighting carbon emissions. But the idea is that when you establish a protected area or you establish a national park or anything of that sort, what you're doing is you're reducing the cumulative pressures on wildlife, right? So if there's less fishing, then the species has a higher population abundance, and therefore they're able to adjust to a changing climate better, right? So let's see, what do I got next? So this is a map from one of my chapters, and this shows all of the proposed or existing marine protected areas around Antarctica. So the two that exist are shown in purple and blue. So in purple is the South Orkneys Island MPA that was established back in 2009. And in blue, all the different shades are the different zones of the Ross Sea MPA that was established in 2016. And the Ross Sea MPA is the largest on Earth. It's absolutely massive. It's about 1.5 million square kilometers. The other three that are shown here in shades of green in the two reds are proposed marine protected areas. So on the east side, so I got a cursor here. So here you can see the East Antarctic MPA. Over here, here is the Weddell Sea MPA, and this is the Domain 1 proposal. Okay. So we're at 20 minutes. That's actually probably perfect timing. And what I'm going to do next is I'm going to jump into a little bit of my research for you. I feel like I've given you a little bit of a baseline when it comes to the continent, to governance, to the agreements that sort of manage it and make all these decisions, and some of the questions that are being discussed right now. And so that's kind of where I want to go, is I want to talk a little bit about the questions that conservation biologists are thinking about in this particular context these days, right? So my research is really focusing on how it is that we design and establish and negotiate marine protected areas in Antarctica. Of course, I'm trying to think about how there are parallels to other systems around the world. I'm trying to think about how some of the lessons we learned in this particular context are transferable. We could probably talk about that for days, but right now, there are these negotiations that are taking place at the UN, and they are trying to basically negotiate a new instrument or agreement for global oceans to protect biodiversity in areas beyond national jurisdiction. And so when I say areas beyond national jurisdiction, what I'm talking about are areas that are outside of countries' territorial waters, which extend to up to 200 miles offshore. Okay, so in my research, a lot of what I'm trying to do is understand how various socioeconomic and political factors shape conservation and policy outcomes, shape the agreements or sort of conservation interventions that we make, right? So in short, what I'm trying to ask, I mean, this is a simplification, but how is it that protected area negotiations are affected by other human activities, needs, or concerns? How is it that the ultimate protected area, or sort of the delineation that we put on the map, or the boundaries of it, are shaped, and sort of the zones and the activities that are permitted within it, how is it that those come to be? So I was digging around a few years ago. I was trying to think of, I was trying to come up with a creative and unique way to go about asking some of these questions. And to a large extent, conservation planning has relied very heavily on ecological data, on species counts, on abundance, on distribution, things like that. And there's only recently been this sort of move towards thinking about how we can incorporate non-ecological data in our planning, right? So what I was looking for is, I was looking for sort of theory or methods that would inform that. And this particular idea came up, right? So conservation opportunity is an idea that has sort of been proposed. And it wasn't necessarily developed for this purpose, but it does allow us to consider spatially referenced non-ecological data when we're trying to design protected areas. And the way that conservation opportunity has been defined is as, quote, an advantageous combination of circumstances that allow for goals to be achieved, okay? And those circumstances, whether we're explicit about it or not, are usually social, economic, or political. If I want to go set up a new national park in Florida or California or anywhere in the United States, of course you're going to need local support, right? And local support is going to depend on how economic opportunities might be sort of limited, increased, all those sorts of things. Is it going to be a benefit to the local economy because there will be more tourists, there will be more climbers, more people spending money in restaurants? Or is it going to harm local economies because it's reducing access to resources? So these are the sorts of questions I'm thinking about, like how do those influence the design of or the establishment of protected areas, okay? So back in 2014, there was this paper that came out from this woman, Katie Moon, and a few colleagues, people that I now work with as well. And they defined conservation opportunity, and they came up with 3 different types, and they said that there are existing opportunities, okay? So there are opportunities to implement some sort of conservation intervention. This could be a protected area, in my case, could be a controlled burn program, it could be a wetland restoration, okay? There are all these different types of conservation interventions we could think about. And existing ones are those which represent situations in which there really aren't any barriers to action, right? There's nothing getting in our way. Like we could go out and we could do this tomorrow. We could start restoring the local wetland. We could reforest an area, whatever it might be, okay? The second type of opportunity are called potential opportunities. So these are sort of opportunities in which actors can identify specific barriers to those conservation actions, but they know that the barriers could be removed or changed. And they just need to take action and do that in some way, right? So we might implement a campaign, an advocacy campaign where we get local politicians on board, or we think about how we bring businesses into the fold and get them to support this, right? And finally, fleeting opportunities. So these are opportunities that really consist of sort of brief windows of opportunity that result from unpredictable events, right? So natural disasters, political elections like we had last week, right? So I'm on the science advisory team for a coalition of NGOs that is gearing up to make a big push to expand protected areas in the United States in the next 4 years because of how the election turned out, okay? So, thanks, Tim. So what you're trying to do is you're trying to take advantage of these moments in time, right? So if there's an ice sheet collapse, suddenly there's actually a conservation measure at CAMLR that allows for that to temporarily be designated as a protected area for 10 years for scientific study, because we want to understand how the disappearance of an ice sheet is affecting the benthic environment underneath that ice sheet, right? So in this case, though, of course, what I'm defining as an opportunity is the chance of designating a marine protected area, okay? So I have this, I keep looking up at you all because you're over on this other screen, but I know you're actually here, so sorry I keep looking away. But let me talk a little bit about my research objectives here. So what I wanted to do is I wanted to know if the concept of conservation opportunity that was presented in this framework was something that actually made sense to individuals, right? So like it makes sense to me as a researcher, but what about all of these people that are making these decisions? Is it something that's accessible or not, right? Second, I really wanted to identify areas of need and opportunity. So areas of conservation need are places that I'm defining as needing some sort of intervention, right? Like they need a protected area to protect a species or habitat or whatever it may be. And opportunity, of course, are just defined as well. So opportunities are places where we think we can actually do that. Where do we want to do it? Where can we do it? And the last thing that I really wanted to do is I wanted to know what different sort of factors are influencing participant selections of these various areas, because I want to understand the importance of biophysical or socioeconomic or geopolitical or scientific drivers, right? Like what is it that's leading them to think that areas could be set aside for conservation purposes? So the first thing I did was I built a survey, big questionnaire. And I was asking participants which areas needed to be protected, which areas they thought could be protected, and for all of those questions, why they thought this is the case. But what I really wanted is I wanted this to be spatially referenced data. Okay, so everything was built around a participatory mapping exercise. And I used this online web-based platform called C-Sketch that was developed by the University of California, Santa Barbara. And it was used for designing the network of marine protected areas in California. Okay. And so what I did is I linked each of my questions to a set of directions that instructed participants to try and digitize different polygons that corresponded to the questions and their answers. Okay. So in the bottom right here, you can see these are some of the areas that people drew. And for each of them, then there was associated attribute data, right? So any of you who've taken GIS, you can imagine I imported these into ARC. I pulled them up and I could click on each of those polygons. I could attach the data and I would have all this information about why they chose it, right? So there are a couple of different things I could do, okay? So I collected data from about 24 individuals in the end from 11 different delegations. So some of these people were their chief negotiators, right? So they're State Department diplomats. Some of them are the heads of their national Antarctic programs. Some of them were their chief scientists. And they were giving me all of this data and they were sort of identifying places. And what I was doing is I was trying to understand like how that overlapped. So I'm gonna explain a few different things here. Okay, so this one, let me walk you through what I've got here. So this was the first question. Did anybody actually understand this framework and is this useful? Because what I wanted to know is, can we use this going forward to actually structure how it is that we collect spatial data about conservation opportunities? And you can see there were three different types of responses, right? So there were non-responses, there were people who responded and clearly understood, and there were people who responded and just did not understand. And the way that I had to do this, I had to go through and I had to look at each of these polygons and they would explain why it is that they chose something. And the question was like, well, does that actually fit the definition of this particular type of opportunity, right? So the number of people who responded and actually found this concept accessible, it declined over here on the left over time, right? So existing opportunities are pretty easy for us all to understand. But by the time we get to fleeting opportunities, people are a little bit more confused, okay? In the middle here are people who responded, but they got it wrong, right? So they said, oh, well, here's a fleeting opportunity, but it didn't make any sense whatsoever in the context of that particular thing, right? So it's not necessarily that they weren't giving me polygons or they weren't identifying places on the map that were opportunities, but what they were doing is they were identifying places that didn't really match that particular definition, okay? So they're all opportunities, they're just labeling them wrong, right? So I've got a few different quotes here as well, because the other thing I was trying to do was, like I explained, I was trying to identify some of these key drivers, okay? So these are three different example quotes from survey responses. So one person said the Gerlache Strait is a critical area for penguin foraging during the breeding season. Okay, that's a reason to protect it. We know that it's important for this particular life stage of a species, right? Similarly, somebody also said high-level political engagement by all actors that have a claim to the Antarctic Peninsula. So that's what they need. That's what provides an opportunity, right? So John Kerry was very involved in this process in 2016 and dictating how negotiations were going from Washington, D.C., right? Obama was very involved in 2015 in calling President Xi and getting Chinese support for the Ross Sea MPA, okay? So at a certain level, the negotiations that take place in the room are one component, but you also need this high level buy-in from others, okay? And the last quote here is, somebody said, we need clarity on the interaction between MPA provisions and the krill fishery management measures. So there are all these sort of other questions or sort of dynamics that are taking place within the marine environment that are still unknowns, right? There are scientific unknowns that need to, there needs to be more research on them. They would help influence sort of how these negotiations take place, okay? But here's the spatial data. This is probably, this is easier for me to sort of convey in a short format here. But here on the left, you have a map. These are the areas that people identified as conservation needs, as places that needed to be protected for a variety of reasons, okay? So these are all overlapping polygons. I created heat maps in GIS, pretty straightforward process. And the areas in red are the ones that are in more need of protection, right? So you can see that those are located further north along the peninsula, right? In the northwest of the peninsula and around some of these subantarctic islands, right? The South Shetlands, Elephant Island, South Orkneys, okay? On the right-hand side, though, you can see that these polygons over here, there's a different pattern, right? So first of all, you see that this has been pushed further south. This orange we're finding further south along the peninsula. You're also seeing a lot of areas that are offshore that have been identified as well, okay? So what this is suggesting are a few different things. One is that, and I'm going to get to this actually in a few slides as well. We're going to loop back to this whole idea. But these areas the areas of need are much more restricted in size and they're inshore. And that reflects where it is that people are working to some extent, right? So people work at Antarctic bases along the peninsula, their research is coastal. There's much less that's known about pelagic environments, about offshore areas. So opportunities, though, are places that are less likely to overlap with human activity, right? So a lot of the fishing that takes place in the Antarctic Peninsula takes place around here. So the reason that they're being identified as needing some sort of protection is because they overlap or they're threatened by fisheries, right? On the right-hand side, if that's where a lot of that activity is, both fishing and tourism, then the other places, it's going to be easier to establish protected areas because there's less conflict between the two, right? Okay, so this all really makes sense in terms of where we find people working, what we would expect to see, how opportunities overlap or sort of conflict with human activities. Okay. But I built off of that. Okay, so this is the last of the four sort of sections here, and this is another one of my research projects and chapters. And what I want to do is I want to go back to that concept of conservation planning and that I explained at the beginning, which really suggests how it is that we prioritize space, how we engage with stakeholders, and how it is that we efficiently allocate scarce resources, right? So the problem with that premise is that this model really assumes that we have lots of sufficient high quality data to underpin all of our planning efforts, right? That we have all the data layers we could possibly need about Antarctica, that we know where every species is located, we have accurate information on their abundance, all of those sorts of things, okay? But that's never the reality in any ecosystem, especially Antarctica. It's not cheap to get there. It's not easy to work there. There are lots of unknowns, okay? So what do we do in those instances? Like, what if we don't have detailed species counts, right? Detailed species of like distribution data. And what if we don't understand a lot of these sort of social and economic or political factors and how it is that they influence the system we're looking at, whether that's Antarctica or that's somewhere in the South Pacific or that's in the Chesapeake Bay, right? All of these places have humans that are doing things, right? We think of Antarctica as being very remote, very unpeopled, but that's not the case, right? Like there are lots of people there. There are lots of people doing things there. There are lots of people visiting there. So we have to think about how those activities are sort of shaping management efforts and sort of conservation interventions, right? Okay, so what we frequently do in conservation then, or in natural resource management, is we turn to expert knowledge, okay? So as Tara Martin, an author, a researcher whose work I really like, has defined it, she said, expert knowledge is substantive information on like a particular topic that is not widely known to others, right? So we all know lots of experts. We all go to experts, right? Whether you're a faculty member reaching out to a colleague who knows more about something, or your student going to your professor and asking, well, how does this work? I don't understand this particular reading, right? There are always people who are specialists in a particular subject area. So in short, what we do is we get a bunch of people together in a room who know a lot about a subject, and we ask them what we should do. And this is common. This is like how conservation works much of the time, right? And I'm how do I say this? I'm really underselling this though, right? I'm making it sound very haphazard and ad hoc, which sometimes it can be. But expert elicitation is actually a very well-developed method across most scientific fields, whether it's engineering or it's medicine or it's political science. We rely on experts and expert elicitation all the time, okay? So on the top right, here's an example of a community planning effort in East Africa. I think this is in Mozambique. And on the bottom right, this is Frank Luntz, who's a really famous pollster here in the US, conducting a focus group for CBS News, okay? So we want to understand how voters think about what they think about the election or how they're thinking about politics. We go and we ask them. And there are lots of methods and structures and approaches to doing that. We can do that in a very scientific way, right? So I frequently say to people, a lot of my research, I have suspicions at the outset based on conversations that I have at CAMLAR meetings, sitting around talking to people over a beer. But that's not a rigorous scientific investigation of something. We have to think of a better way to ask those questions and see if they're consistent across groups, across individuals, all over the place, right? Is this just something that somebody tossed out on a whim, or is there some pattern, right? Science is about looking for patterns, okay? So one form of elicitation, and this is one that I used in this chapter, is called forecasting. And it's been increasingly used by environmental scientists to try and obtain expert knowledge or judgments about uncertain quantities or events in probabilistic form, okay? So as a percent. So for example, forecasting methods are often used to parameterize Bayesian models of how systems they function or interact, or how a change to a system might cascade throughout it, right? Okay, so I talked to you a minute ago about how expert elicitation has been used in conservation. But for this project, what I was trying to do is I really wanted to see how forecasting methods could be used to predict conservation outcomes and inform protected area planning, right? So I wanted to forecast the likelihood that various areas along the Antarctic Peninsula will be designated as marine protected areas within the next 8 years. And second, I really wanted to assess the importance of these various factors that I've been talking about. How is it that they're shaping those forecasts? Right? So I showed you this image here, okay, and I built off of it, okay. So in these areas, I used some statistical tests to pull out different clusters, okay. I needed to identify 10 different geographic areas around the peninsula. So you'll see those on the next map, right? But you can see there's obviously a cluster here. There's obviously a cluster here, right? There are different places that sort of pop out in the data. So these are those 10 areas, okay? So I pulled those 10 areas out and I presented them to people. And we used another questionnaire basically to ask them what the likelihood was that these areas would be designated. So I wanted high, best, and low estimates, okay? Here's an example on the bottom right of this image here, this figure here. You can see these are 10 estimates from 10 different individuals, okay? Now, the dot and the two ends are the three numbers, okay? This isn't a single measure with confidence intervals around it. This is three separate measures. This is just how it's shown in the literature. This is how we sort of illustrate it. Okay. So let me explain a little bit about what we found here, okay? When we combined all of this information, these are the estimates of the likelihood that various areas are included or established as protected areas, right? So first of all, like I said, these are three separate measures, and each dot or the end of each line represents 10 averaged estimates from 10 experts who were involved in this, okay? You can see the highest best estimate was around 58.5% and the lowest was around 18%, okay? So here the Bransfield, that's about 18. Up here, I think it was Marguerite Bay or Southwest Alexander, that was 58.5, okay? And you can see these are lined up north to south, okay? So there's a bit of a latitudinal gradient, right? This obviously stands out. I could explain that to you. There are a few quirks in some of this data. But what I'm really trying to highlight here is that there is this north to south gradient, okay? So let me get some more of those results. And that second question I asked was, what is the importance of various biophysical, socioeconomic, and geopolitical factors? Okay. And in these four groups, for each of the geographic locations, what I was doing is I was asking participants to identify the factors that influence those quantitative forecasts they were making, right? Okay, you said it had a 60% likelihood of happening. Why is that? Tell me what the factors were that you were thinking about while you were making that choice, okay? And this was a multi-step process. So everybody individually made estimates. We all discussed them as a group, as if we were in a workshop. And then they went back and they made new estimates, right? They revised their estimates. This is called a Delphi method. This is sort of a process that you go through to be more thoughtful. And you're not trying to get to consensus, but you are trying to get people to think about other factors that didn't really influence their initial estimate, okay? So here, these are the selections, right? And this is the final data. This is not the first cut of the data before we sort of cut the list down. And so we started out with 23 factors. They made their choices. We shrunk it. They made new choices in the second round. And here in the selection frequency column, you can see the number of times that each of those factors was selected by participants, by these experts. And then on the right-hand side, you can see this column is how they ranked then, right? So numbers 1 and 2 are right here, right? So it turns out that geopolitical factors are the ones that really influence how people perceive or sort of like the perceptions of the likelihood that protected areas will be designated, right? Here, number 3, existing fisheries. So economic activities. That's not surprising to us at all. We always see these conflicts. Concerns about implementing or establishing new national parks generally revolve around how that's going to limit access to resources, right? So I could talk about each of the columns here in this table. Okay, this is a hotspot map of some of that data, and what I want to focus on are columns 4 and 5, right? So right here, this column and this column. Okay. Now look through this column and you can see a pattern emerge. Right at the top, the numbers are much lower. So for this one, here's an outlier. I can talk about that. And here it's reversed. Here it's much higher at the top, much lower at the bottom. Okay. So as areas in the north warm, it's expected that a lot of species ranges are going to shift further south. That means that the areas in the south are potential climate refugia for these species. Okay. So that's what this data is showing, right? The qualitative data, when we go back to it and say, well, why is it that you chose this particular factor? People say, well, it's because we know that species are going to be impacted in the north, and we know that there's a higher likelihood of areas to the south serving as refuges for these animals, right? So we think it's more likely that areas in the south will be designated for that reason, okay? If you go to that next column then, existing fisheries, the reason that people were suggesting areas in the north are less likely to be designated is because fisheries are there, whereas the fisheries don't really operate along the southwest of the peninsula, right? So other things that pop out in this data, right? So I had to go dig around and figure out why there's a 6 here for the Joinville and Danger Island area. This is right at the tip of the peninsula. So basically what's happening is this is a local dynamic, right? So at the tip of the peninsula, you have cold, deep water currents that are actually circulating around the peninsula out of the Weddell Sea, and it helps create a microclimate that's much colder than the surrounding area. So this area is likely to be safe for wildlife for a much longer time, right? So that's the case. I mean, like I said, I could spend a lot of time on this, but all of these numbers, when you dig into the qualitative data, it sort of explains like what you're seeing there, which is really interesting, right? So these 3 columns are about fishing, but they're inverses of each other, right? So they're existing fisheries and a lack of fisheries. So of course, this column, the numbers are higher at the bottom, whereas this one, they're higher at the top. There's fishing there. Well, that doesn't make sense. Of course, there's no lack of fishing there, right? Okay, so that's it. I'm going to leave you with that. I'm going to let you ask all the questions you want. I just want to thank all of my funders and co-authors. So Duke, of course, has been funding a lot of this. I've been funded by National Geographic for all of my field work for the last few years. I spent 6 months in Australia at James Cook University. And I want to thank the IUCN and Antarctic and Southern Ocean coalitions are taking me to all these meetings. These are some of the groups that if you're interested in some of this work, you could look up. And then these are all of my co-authors, my committee members, my advisor up in the top left here, for all of their help on this as well. And with that, I will take any questions that you might have.
Yeah, thank you so much. That was very interesting. So any questions for Seth?
I have a question, Seth. So when you showed the map of how all the marine reserves were in remote areas, it reminded me of my early Yellowstone research. And historian Alfred Runney made the argument called the worthless lands argument, that the only reason Yellowstone was set aside is because it was pretty much worthless, high rock, wilderness areas. And I thought about George W. Bush's national monument in the Hawaiian Islands, which I'm not going to try and pronounce. And the talk at the time was, no one, it's too remote, it's not going to hurt fishing, it's not going to do any harm. And so is that the feeling you get, that most of these are set aside because, no one really cares, it doesn't hurt anything?
Yeah. So there's a lot of interesting stuff to unpack here. So in the literature, there's a discussion about how originally conservation planning was very opportunistic, right? It was, nobody lives there, it's a pretty place, we'll set it aside. And there was no real thought given to what the benefits of doing so were, whether those benefits are sort of social and economic in terms of we want to rebuild fisheries, or they are ecological benefits in terms of we want to benefit, we want this protected area to benefit species and improve the status of various wildlife. So over time, conservation planning really evolved as sort of a response to that. So how is it that we are more intentional about setting our objectives and designing protected areas to achieve those objectives? And now it's interesting, there's been a bit of a return, they've hit an equilibrium, right? It's like we started here and then we went here and then we've started to go back this way. Because at that middle stage, we said, well, we're going to establish them only to protect wildlife. Then we forgot that there are all these human communities that we're going to, it was going to create like conflict because we hadn't thought about them, right? So that's sort of what I was getting at throughout some of this is, we have to think about where people are relying on local fish stocks for their livelihoods, right? You can't just completely remove humans from the equation as if they weren't there. And frequently when I think actually on the next slide here, I included these pictures intentionally, because a lot of times the examples that we think about are sort of elephants marauding through people's farms. We think about in India, the concept of fortress conservation, where we're just going to move entire villages and we're going to set aside tiger preserves. But the reality is that still leads to conflict, right? It leads to tigers taking wild, farm animals, or people being killed by them. So to get to your question, though, I think that a lot of what's happening now is that like a lot of the easy places to set aside have been taken. And yeah, longline fisheries don't really operate in the Northwest Hawaiian Islands. And so it was easier to do that. There was initially an argument, the pushback against the potential designation of let's see if I can get it, Papahanaumokuakea, was that it was going to impact fisheries. And then there was an analysis done by a bunch of NGOs, and they said, well, okay, so who's fishing there? And they went and they talked to the fishermen and they looked at all of the vessel data. They found nobody's actually fishing there. So it's frequently pushed as like, we can't do this for this reason, but that's not, it turns out that's rarely the case. Now, going forward, that will be a problem for sure. And there is this concern that we're establishing residual reserves, as they're termed, that don't really give us any environmental benefit. And I think it gets harder because now the places where we haven't designated these are the more peopled places. Can you imagine trying to undertake a planning sort of process in either New England in the Bay of Fundy or in the Gulf of Mexico, where you have commercial and recreational fishermen, you have, you know, oil and gas interests, you have conservative governments, you have all of these sort of groups that are anti-conservation and who are unwilling to think about how these designations or management mechanisms could benefit them. And they think, well, I'm not going to have access to the fish that I want to fish. And that's not necessarily the case, right? You can design protected areas in a million different ways. You know, I could pull up an image of the Great Barrier Reef and the Marine Park, and they have a dozen different areas that sort of manage your access. Some places are spearfishing only, some diving is allowed, some no boating is allowed. So it just depends on how you design those areas. But it's definitely going to get harder. Yeah.
Seth, can you dial up one of those couplets of two area maps side by side?
Yeah. How about that one?
Bingo. So in the right picture, I see swaths that look like they were maybe cruises or whatnot. But what intrigues me is the two lineaments of dark blue that parallel the peninsula. And I'm wondering if those are real or if those are some kind of GIS artifact.
There are some GIS artifacts here. So so these are GIS artifacts. This is like when you're changing your projection, you get some of this because the polygons only have X number of actual points. So regardless of how you are doing that conversion, you still end up with straight lines on your data, but not, I mean, like I could fix this red line here, so that wouldn't be the case. But these here, so the way that this was done, I wonder if I could pull up. I have to do this. Oh no. I'm going to find you an image though that will help with this. Basically, individuals were drawing all of these polygons, and so you get overlap. And where is it? Figures. Is it? Oh no, I have no idea where this is. Data analysis. Never try and dig through your folders at a moment's notice. Okay, let me try that again. Let me go back and maybe I can explain it on here. Anyways, what you're seeing here is that this that I'm outlining is a polygon from one person. This is another polygon from someone. And so it just turns out that more of these areas are overlapping offshore than are overlapping in this particular location. It was missed by a few of these. So it's not a smooth gradient, right? Like it's not like you get blue naturally scaling all the way up to this orange. It just means that there were a number of people, there were here probably like, 5, 6, 7 people who they had polygons that all overlapped at this particular location. Does that make sense? And I've got somewhere I have an actual image of all of these polygons, and it's absurd. It was 111 different ones, and it is really interesting to look at how they overlap. So this area, right, you have more confidence in this. This was probably 14, 15 people who identified it. And of course, you can always scale this up, right? So all my numbers are within sort of standard numbers for the size of these groups, right? But yeah, you could do this with 30 people, you could do it with 40 people. You could just keep going up. And the way that I think about it is, I'm not necessarily sure that those numbers, if you were, a good example would be the forecasts, right? Like I could have 50 people doing each of these forecasts. I don't necessarily think that the numbers would be any different, but I do think they would be more robust in the sense that an outlier would be less likely to affect them. Right. I mean, a 10-person workshop of experts for an elicitation is pretty standard. right? People go even lower. So these methods are used frequently in sort of hazard prediction, like what's the chance that this volcano is going to erupt. And they're also used frequently in intelligence analysis, interestingly, and also in other things like engineering, trying to assess like the best way to build things. Yeah.
So Seth, we're coming to the end of the time. A lot of people have already had to go because of classes. Julie had to leave because she's got to teach. But
Yeah.
I have a question, and I don't even know how to really phrase it. But it's CAMLR, like CAMLR, is that it?
Mm-hmm.
And I'm wondering what the current administration, how it has avoided any attacks from the current administration. Is it, or has it? I'm just wondering, not the new administration that's going to come in, but the current one. I'm just curious. And maybe you can just unshare your screen and then we can just talk, unless there's a slide that you want.
Yeah, actually, I don't need to show you this anymore. Let me.
I think you can just stop sharing your. Yeah, there we go.
There we go. Yeah, that's easier than I'm actually looking at you all.
Yeah.
So CAMLR has avoided any real impacts or change of policy under the Trump administration, mainly by virtue of flying under the radar. It's just not important enough, to be honest.
That's what I thought.
Yeah, they're just too busy trying to like cut aid to foreign countries or trying to, well, don't get me started on the other things they're trying to do, right? We could talk about that all day. But they're so busy doing all of those horrendous things that they have forgotten that Antarctica even exists and that the US plays a real role in sort of international marine governance. So it's
lucky. We're lucky for that.
It is to some extent an example of incompetence, right? By not having people in government who know what they're doing or know how to move bureaucracies in the direction that they want, or actually staffing up all of the offices that they are allowed to appoint people to. And so it just, if you want to change what the federal government does, you have to know how to run the federal government. Turns out that running a business is insufficient experience for running a federal agency. They're just different things.
So what's next? What's next for this organization?
Well, that's a really depressing question. So nobody knows. It's part of the reason that I chose this particular topic and was interested in CAMLR in the first place is that it is perceived to be a really incredibly effective international agreement. But the reality is that it is struggling at this point to reach consensus on a lot of things, primarily because of Russian and Chinese intransigence and sort of an unwillingness to put these areas offline. It just has to do with access to resources, right? There's a concern that establishing more protected areas continues to set new precedents, and doing so will reduce access to krill resources, to toothfish, those sorts of things. So I guess I am kind of curious whether that changes over time if tourism continues to increase, right? There's prior to COVID, there was a projected increase of about 33% in the number of vessels going to Antarctica and the number of sort of slots for tourists, right? So Antarctic tourism is exploding. And as that industry grows, my suspicion is that there will become a greater constituency for conservation, and that will start to outweigh fisheries. I don't know if that's the case, but there are starting to be discussions from the United States, the United Kingdom, Australia, France, Germany, Chile, Australia, Argentina, about at what point they say, all right, well, we're not going to allow any more fishing here, right? Because that's to some extent the nuclear option, but we can bring the whole thing to a standstill.
Yeah. Interesting.
Yeah, it's a good question. I don't know. I'm not particularly optimistic, especially after having just survived 2 weeks of Kemmler meetings. Very little is happening, and it's very frustrating. And even agreements on the most simple things, right? There was a big article in, might have been the Washington Post, about how they were unable to really sanction a vessel that was suspected of illegally fishing because Russia insisted that it wasn't. And if people aren't negotiating in good faith, then it's really hard to take collective action. Right. So.
Are there any other questions?
Actually, I had a real quick one, or maybe not so quick. I don't know. Well, first off, I'd like to say congratulations. I mean, getting a PhD is pretty awesome. I'm sure your family's very proud. Hi, Dr. Sykora. But anyways, my question was not so much about your research, but about your education. Being as I'm in between geology and geography, what is your undergraduate experience in, and when did you start having a lot of exposure to the GIS stuff? Like, was that during your undergraduate degree, or did you start doing GIS stuff later?
So I actually took GIS with Dr. Chen there, but that was, at the time, I didn't really know why I was taking it. I was interested in it, but I didn't really have an application yet. And I didn't actually loop back to GIS until about 4 years ago at Duke. And then I took any and every class. So I've actually just got the paperwork sorted out last week. So I got a certificate in geospatial analysis in the end. But I, when I was at Slippery Rock, I was a triple major. I was geography, French, and political science. And then I went off and did a master's at University of Maryland. And I worked throughout most of that. I was either at Department of the Interior, I was at NOAA, I was at the World Wildlife Fund. I was working on a bunch of different conservation projects, whether it was Interior's climate change adaptation plan, whether it was, I was sort of coordinating a sea turtle conservation program with the World Wildlife Fund and serving as a technical advisor to programs around the Caribbean where they were trying to figure out how it was that climate change was going to impact nesting beaches and vulnerable populations. And then I moved to NOAA, and I was working on sort of integrating climate change planning into a lot of regulatory policy and sort of like how we assess the status of different species under the Endangered Species Act or the Marine Mammal Protection Act. And then I was doing a lot of other sort of policy, political things there. It was less science, more on the policy side of things. So I've done a bunch of very different and random things over the last few years, but I hit a point where I just thought, for what I want to do long term, I need to go back for a PhD. And it was a now or never sort of proposition. I didn't want to be doing it when I was 40 or 50 or later in my career.
Hey, watch it.
So yeah, I just think
I'm a non-trad, so
well, I mean, you can do it. It's just like at a certain point, you just have to pull the trigger and say, like, now's the time, right? Now's when I want to.
Yeah, it just seems to me lately, having my finger on the pulse of what's going on with GIS, it seems to be at the cutting edge of everything. Like, we've got so much data pouring in from so many different sensors and satellites and sources that